Welcome aboard. Today we're exploring the structures, systems, and significance of memory, how information moves, where it's stored, and what shapes the accuracy of what we remember. We'll visit three regions: the memory process, the memory systems, and memory effects and distortions. We begin with the memory process, the region shown in blue. Our first stop is encoding, where experiences are converted into memory code, represented by the brain and save icons. Next is storage, where information is retained over time, sometimes briefly, sometimes for a lifetime. Finally, we reach retrieval, symbolized by the magnifying glass and folder, where we access and bring stored information back to awareness. Retrieval connects directly with storage, shown by the solid two-way arrow. This is the core process of accessing and returning information. The dotted arrow between retrieval and encoding shows that when memories are recalled, they can be updated and re-encoded before being stored again, meaning each act of remembering subtly reshapes a memory. Memory isn't just a fixed recording, it's active and reconstructive. Now we arrive at memory systems, the green warehouse-shaped region. At the base is sensory memory, shown by the eyes and ears. It briefly captures raw sensory input, most of which fades instantly, though some travels along the dashed arrow to working memory, where attention filters what's worth keeping. There's also a two-way link between sensory memory and encoding, showing how attention both receives and shapes what we notice. Next is short-term memory, symbolized by the briefcase, a temporary holding space for small amounts of information. The two-way arrow to storage shows that what's rehearsed can move into long-term memory, while recalled information can be briefly returned here for use. Working memory, represented by the abacus, is our mental workspace, where we hold and manipulate information, linking what we perceive with what we already know. Finally, long-term memory, shown by the storage box and thought cloud, is our lasting store of knowledge and experiences. Its two-way link with retrieval shows how memories are recalled and sometimes rewritten, creating a continuous loop among the systems. Our final region is memory effects and distortions, shown in pink. On the left, effects enhance recall. The recency effect, marked by the finish line flags, help us remember the most recent items, still active in short-term memory. The primacy effect, with the first place medal, reflects how early items are remembered best because they've been rehearsed into long-term storage. On the right, distortions reveal how memory can mislead us. The misinformation effect, shown by the fake news icon, occurs when post-event details alter what we recall. False memories, represented by the brain and X, are recollections of events that never happened, our brain's creative reconstruction. These influences are most apparent during retrieval when memories are pieced together, but they can also bias and reshape storage over time, as shown by the solid and dashed feedback arrows. Thanks for joining me on this journey. Memory is a dynamic system. It doesn't just record life, it rebuilds it. It encodes, stores, and retrieves information, preserving experience while blending it with imagination. Each time we remember, we're not just looking back, we're recreating the story anew.